So in this video, we will be learning how to add fractions. And as normal, these videos are intended for students being tutored at Sure Success Tuition. The courses we tutoring are on the screen. The number to call is on the screen, so feel free to call if you are interested. Also, if you found anything valuable in the video, you could like and subscribe. So let's do some review of some basic concepts. So we're going to review like terms. So recall if we were to have 3 apples and we added 2 apples, we would have a total of 5 apples. If we had 3 trucks and we added 2 trucks, we would have a total of 5 trucks. Now, if we were to have 3 apples and we added 2 trucks, what would we have? Well, we have no idea. There'll be 5 of something, but what exactly, we don't know. So this is important to remember. We can only add like things. So that is critical to remember. We can only add like things, apples to apples, trucks with trucks. We cannot add unlike things in a way that combines them into a single term. We just cannot do it. So just as we can only add like things, we can only add like fractions. So like fractions are fractions that have the same denominator. So if you have 3/6 plus 2/6, that will give us 5/6. But we cannot add 3/6 plus 2/5 just like that. They are unlike. Now, this also applies with subtraction. We could only subtract like fractions or like terms. Now, equivalent fractions, quick review. Equivalent fractions are different fractions that have the same value. So that is important. They have the same value. Now, how can different fractions have the same value? Well, look at this comparison. So you have 3 persons with different, not amount of money, but one person has $100 as a bill, another person has two $50 bills, and this final person, they have 4 20s and 2 10s. But if we notice, the value is the same. When you add all up, it is still $100 each person has. So the value is the same, although the bills are different, the values are the same. So bear that in mind. Something could have the same value, but be quite different in its representation. So if we notice these circles here, let's see the fraction that is shaded red. So in this circle, we are seeing it's divided into 2 equal parts. So one is shaded red. So it's 1/2, 1/2. In this circle, it's divided into 4 equal parts. 2 are shaded red. So we name this 2/4. This one, 6 equal parts, 3 shaded red, so it's 3/6. So if we notice, since these circles are the same size, and then the fraction that is shaded red, they have the same value. So that is important. Different fractions, but they have the same value. That is what equivalent fractions are. So just as money could have the same value but be represented in different ways, fractions can also have the same value but be represented in different ways. So look back at the money. All these values are equal regardless of how it was represented. Similarly, all these fractions are equal regardless of how it is represented. So the value is the same, but the way it is represented is different. So we have 1/4 being added to 2/3. So these are unlike fractions. We must convert them into like fractions. So that is important. We must convert unlike fractions to like fractions in order to add them. But how can we convert a set of unlike fractions into like fractions? How do we do that? Well, we need to find equivalent fractions that have the same denominator. And what number should we use as the denominator? Well, we could use any common multiple of all the denominators. However, if we use the LCM of the denominators as the common denominator for the new fractions, we would not have to work with big numbers unnecessarily. And you all know we try to avoid working with big numbers if we can. It makes our calculations faster and the chance of making errors reduces. So let's see some common multiples of 4 and 3. So we will have 12, 24, 36, and these could go on forever. So we could take any of these common multiples and use them for the denominator of our new fractions. So let's take the LCM, which is 12. So we're going to convert a quarter into an equivalent fraction. However, the denominator must be 12. So how do we do that? How do we move from 4 to 12 to turn it into equivalent fractions? Well, we multiply here by 3. So 4 multiplied by 3 is 12. And if we multiply the denominator by 3, we multiply the numerator by 3. 1 multiplied by 3 is 3. So 1/4 has the same value as 3 over 12. Now we need to do the same thing with 2/3. That has to turn into a fraction where 12 is the denominator. So how do we move from 3 to the 12? We multiply by 4. If we multiplied the denominator by 4, we must multiply numerator by 4. So this will turn to 8. So it is important at this point to notice that the value of the original fractions did not change when we converted them. So our new problem will then be 3 over 12 plus 8 over 12. This problem has the same value as our original problem. The values here are the same. No difference in the value. The only difference is that here we had unlike fractions. Here we have like fractions. So we converted them. And since they are like apples with apples, so to speak, we can perform the addition. So we'd have 11 over 12. Very simple. So remember that we used the LCM previously, but we can use any of the common multiples. And once we perform the operations properly, the answer will still be the same. However, if we don't use the LCM, we may have to do more simplifying. So let's look. So we used 12 before as the common multiple, but let's try 24 this time. So a quarter being converted into an equivalent fraction where 24 is the denominator. So how do we move from 4 to 24? Multiplied by 6. So we multiply 1 by 6. So it's 6 over 24. 2/3, we multiply by 8. Numerator and denominator multiplied by 8. 16 over 24. So again, the original fractions, their value did not change. So our new problem still has the same value as the original problem. It's just differently expressed. So we have 6 over 24 being added to 16 over 24. We have 22 over 24. However, we notice that this fraction here could be simplified. We could cancel the common factor of 2. So 2 into 22 is 11. 2 into 24 is 12. So again, same answer, 11 over 12. Now, we can also cross multiply to find like denominator fractions. Sometimes cross multiplying might be the faster method. So let's see how to cross multiply. So if we have a quarter being added to 2/3, we multiply the numerator of the first fraction by the denominator of the second fraction. So look at it here. This 1 is being multiplied by the 3. 1 is the numerator of the first fraction. The first fraction is a quarter. The second fraction is 2/3. And the denominator of that fraction is the 3. So 1 multiplied by 3. Notice I'm putting the 3 above the 1. So I will know which fraction it corresponds to when we finish. The second step, we multiply the numerator of the second fraction by the denominator of the first. So in this case, it will be 2 multiplied by 4. That's 8. And the final third multiplication step, we multiply both the denominators. So 3 multiplied by 4 is 12. So now we would have two sets of fractions. We would have 3 over 12 plus 8 over 12. Again, 11 over 12. In this situation, we happen to just get the LCM when we multiplied, cross-multiplied. It doesn't work out all the time where you will get the LCM, but we are happy that it was the LCM. Now, there are certain instances when we would not cross-multiply, when cross-multiplying would actually be more difficult. So if one denominator is a multiple of the other, it is usually best not to cross-multiply because you will be working with big numbers unnecessarily. For example, 1/2 plus 7/8. Now, right away, we can see that 8 is a multiple of 2. So in this instance, we would not cross-multiply because we would end up working with bigger numbers than necessarily. Well, let's see what happens when we cross-multiply. So 1 by 8 is 8. 2 by 7 is 14. 2 8s are 16. So our new fractions, our new problem would be 8 over 16 plus 14 over 16. That's equal to 22 over 16. Now we have to simplify, canceling the common factor of 2. 2 into 22, 11. 2 into 16 is 8. After we finish that simplification, we have 11 over 8. For primary school purposes, you must convert into mixed numbers. So we have 1 and 3 all over 8 as our final answer. Notice we had to work with 16ths. However, we could clearly see that 8 is a multiple of 2. So let's use the LCM method and be done with it. We can clearly see that the LCM here would definitely be 8. So half turn it into something with 8, equivalent fraction with 8. Multiplied by 4, multiplied by 4. So we'll have 4 8s. Since it's already 8s we are working with, we don't need to do anything to 7 8s. That's already in the form of 8s. So our new problem would be 4 8s plus 7 8s, which is 11 8s. Primary school students, you would have to convert into mixed numbers, 1 and 3 8s. So really simple stuff here. Now look again when not to cross multiply. So sometimes we may be able to look at numbers and we would be able to spot quite easily what the LCM would be. If we spot what the LCM would be, there may be no need to cross multiply. So for example, we are seeing here a quarter plus 5 over 6. Now what is the LCM here? We could see it's easy, it's 12. But let's cross multiply and see what happens. So 1 over 4 and 5 over 6. We cross multiply, we get 1 by 6 is 6, 5 by 4 is 20, 6 4s are 24. So our new problem would be 6 over 24 plus 20 over 24. That gives us 26 over 24. We're simplifying this here now. We'll have 13 over 12, and that will give us 1 and 1/12. So notice we had to work with 24. But the LCM, as we saw, we could spot the LCM, which is 12. So a quarter turning as a fraction, where 12 is a denominator. We multiply the 4 by 3 to get the 12. So we take the 1 and multiply it by 3. So we have 3 over 12. 3 over 12 has the same value as 1/4. Let's take the 5/6. We multiply the 6 by the 2, and we take the 5 multiplied by 2 also. 10 over 12. So our new problem would be 3 over 12 plus 10 over 12 gives us 13 over 12. And we have 1 over 12. Again, we did not have to simplify at the end. But it should be noted that regardless of the method that we use, we will get the same answer once we follow the steps properly. So again, this here is important. We cannot cross multiply if we must add or subtract more than 2 fractions. So if you have these 3 fractions, 1/4 plus 5/6 plus 2/3, there's no way we could cross multiply. So let's look at this here. Let's try to cross multiply the first 2. So we would have a quarter, and we have 6 over 24 being added to 20 over 24. But that's just the 2 fractions converted. to like fractions, but we still have the third fraction, we still have the 2/3. So we have to add that. So notice what we have here, notice the problem. All of the first two fractions have been turned into like fractions. The third fraction still is a third, so it makes it unlike. The whole set of fractions still unlike. So these are like, this one make it unlike. So we cannot cross multiply when it's more than two sets of fractions. So let's work the LCM method. So a quarter, we see the LCM is 12. So let's convert a quarter into something as 12ths, and we will have 3 12ths. 5 6 into 12ths would be 10 12ths, and 2/3 into 12ths would be 8 12ths. So our new problem would end up being 3 12ths plus 10 12ths plus 8 12ths, 21 over 12. Cancel the 3, cancel the 3. We'll have 1 3/4. So give this a try. So at this point, you pause the video, and when you finish working this question, start back the video and we'll work the solution. So pause the video. Please pause the video, work out the question. Pause it and work out the question. Right, so let's solve this question here. So you have many methods you can use. So let's try the LCM method. So the LCM of 5 and 7 is 35. So 2/3 going to turn into a fraction where 35 is the denominator. We have to multiply by 7. So we multiply the 2 by 7. 14 over 35. Now we have 4 7s going to turn into a fraction where 35 is the denominator. How do we do that? We multiply by 5. So we multiply the 4 by 5. 20 over 35. So our new problem would be 14 over 35 plus 20 over 35. That would give us 34 over 35 as our final answer. Or we could have cross multiplied. In this case, because we have two prime numbers, especially as the denominators, we will get back the same LCM, which is quite nice when you cross multiply. And we'll have 2 by 7 is 14. We have 4 by 5, 20. 5 by 7, 35. So we have 14 over 35 plus 20 over 35, 34 over 35. So that's our final answer. Did you get that? I hope you did. So now pause the video again at this point. Please pause the video. Work this question out. When you have finished working the question, play the video again and we'll solve it. So pause it at this point. Please pause the video and solve the question. Okay, so let's solve it here now. So 3 fractions, we must use LCM method. So we cannot use cross multiplying, and we are seeing that the LCM here is 20. So we have to multiply 2 by 10 to reach 20. So we multiply 1 by 10. So that's 10 over 20. The quarter, we multiply it by 5. The 4 by 5 would give us the 20. So 1 by 5 is 5. And then the 5 must be multiplied by 4 to give us 20. So the 3 has to multiply by 4 also. 3 4s, 12. So what would be our new problem? That would be 10 over 20 plus 5 over 20 plus 12 over 20, giving us 27 over 20. Secondary school students could leave your answer like this. However, primary school students, you must convert into mixed numbers, 1 7/20. Now, sometimes we may not be able to spot the LCM, and it might be challenging, time-consuming, trying to work out the LCM. So at times, it may very well be easier just to multiply the denominators. And once you multiply the denominators, the answer would be a multiple of all, a common multiple. It might not be the lowest common multiple, but it would be a common multiple And it does not make a difference which common multiple we use, the answer would be the same in the end. So let's multiply the denominators. What we have here, 5 by 4 is 20, by 2 is 40. So we're going to turn a half into a fraction that is equivalent, but the denominator has to be 40. So what do? We multiply the 2 by 20 to get the 40. So we must also multiply the 1 by 20. So we'll have 20 over 40. And we can see that that is a half. The value is the same. A quarter, how do we reach the 40 for the denominator? We multiply it by 10. So we multiply the 1 by 10 also. So that's 10 over 40. 3/5, we multiply by 8. 3 by 8 is 24. So our new problem would then be 20 over 40 plus 10 over 40 plus 24 over 40. So we have 54 over 40. Again, because it was not the LCM, we have bigger numbers to work with. So yes, we will have to simplify. So we simplify and we will end up with 27 over 20, and we have 1 and 7/20. So we reached the adding mixed numbers. So how do we do that? There are several ways in which we can add mixed numbers. So one, we could first convert the mixed numbers into improper fractions and then add as normal. However, we may end up working with bigger numbers than necessary if we do this method. The second method is to add the whole numbers first and then add the fractional parts. Again, if we do this, we may have to do some regrouping to get our final answer. So both methods has its advantages and disadvantages. The more you practice, you would realize which one to do in any given situation. So let's try this. So you pause the video and try this. You must think, try this question. All right, so let's look at it. So let's try first converting into improper fractions. Let's give this a try. So as improper fractions, we end up with 19 over 5 plus 29 over 4. Again, these are unlike fractions, so we need to convert them. The LCM is 20, as we could see. So 19 over 5 would be equivalent to 76 over 20. And 29 over 4 would be equivalent to 145 over 20. So our new problem would then be 76 over 20 plus 145 over 20. We'll have 221 over 20. Converting this, we'll have 11 and 1/20. So notice, again, because we converted them into improper fractions first, we had to work with some very, very big numbers. 221, 145, 76, some big numbers we had to work with. However, let's try adding the whole numbers first. So let's add the 3 plus the 7. These are the whole numbers. We'll have 10. Now, in reality, when we add these, we'll end up with really 10 and 4/5 being added to 1/4, right? That is what we will end up having. So let's bear that in mind. This 10 that we have here at the side here, this 10 is actually going with this first fraction here. Now, we bring back down our fractions. We're going to add the fractional parts. So 4/5 plus 1/4, we need to convert them. So 4/5 would be converted into 16 over 20. And 1/4 would be converted into 5 over 20. So our new problem would be 16 over 20 plus 5 over 20, which will give us 21 over 20. And we had to do some regrouping. So we have 1 and 1/20. However, this is not our final answer, because remember we had this 10 here. So remember that 10 there. So after we regrouped, we have to add this 10. So 10 plus 1 and 1/20 will give us 11 and 1/20. So notice at the end of the day, the answer here is the same. So regardless of the method, the answer would still be the same. So now you give this question a try. So please pause the video and try your best to work this question. Right, so let's try converting to improper fractions first. We'll have this pair of improper fractions, 7 over 4 plus 19 over 3. We need to convert them, so we would have 21 over 12, and we would have 76 over 12. So our new problem would be 21 over 12 plus 76 over 12, giving us 97 over 12. Primary school students, you must convert into mixed numbers. So we end up with 8 and 112. Again, we worked with some big numbers here. So let's add the whole numbers first in this method. That's the 1 and the 6, and we'll get 7. Now let's add the fractional parts. Again, we still need to convert the fractions because they are unlike. So 3/4 will give us 9/12, and 1/3 would give us 4/12. So that would be our new problem. 9/12 plus 4/12, 13 over 12. We need to regroup this, convert this. So we have 1 and 1/12. However, we must remember our whole number. So 7 plus 1 and 1/12 gives us 8 and 1/12. Students, many times when we work in the margin here and add the whole numbers, sometimes we forget to include it in the final answer. Please do not make such a foolish and careless mistake. Always think about what you are doing. Do not work like a robot.